Hello once again. How are you, my dear students? Welcome back for another video lesson in mathematics. Hope everybody is doing great and all are safe. Let us continue with our lesson with patterns and sequences for lesson 4 in arithmetic sequence. This time we are going to find the missing terms and the nth term of the sequence. This is still part of our module 1 of quarter 1 for mathematics 10. So let's begin. Before we continue, please don't forget to like and subscribe on our YouTube channel to keep updated with upcoming video lessons in mathematics. And remember, you can always pause and play this video anytime whenever is necessary. You can even play back the portion of the video you want to revisit to attain mastery. That's it. I think we are all ready for the lesson. What you need to know. At the end of this lesson, you will be able to find the missing terms and the nth term of the arithmetic sequence. Let us first look back on what we have learned in our previous lesson. It is important that you have gone through the previous lesson before you proceed to this video. Remember that an arithmetic sequence adds or subtracts a fixed amount of value, which we refer to as the common difference, to get the next term in the sequence. Subtract the first term from the second term to find the common difference if you know you have an arithmetic sequence. Now, let's have a short activity. Which of the following cannot be three consecutive terms of the arithmetic sequence? The correct answer is 23, 45, and 69. Do we have the same answer? Great! Now let us check each sequence how we arrive with our answer. The first sequence, if we subtract 44 with 23 and 65 with 44, they arrive with the same answer. So it is an arithmetic sequence then. For the second sequence, when we subtract 55 with 33 and 77 with 55, the same. Both have the same answer. So it is also an arithmetic sequence. For the last sequence, when we subtract 45 with 23, then 69 with 45, both operations arrive with different answer. That is why that is our correct answer. Great! Now that we refreshes our mind, we are now ready to tackle the lesson. Let's start. Let us go back to our activity on matchsticks, wherein the number of squares represents the number of terms, or the position, and the matchsticks are used as the value of each term. As we move to the next term, the number of matchsticks increases with the same value that is being added to it. So from 4, we added 3. That is why it becomes 7. Add again a 3, becomes 10, and so on. So we say a sub 1 is the first term, adding the common difference, which is d, to each successive term is as follows. The first term is indicated as a sub 1. Then the second term will be written a sub 2. And in a sub 2, we have a sub 1 added by d, which is again our common difference. So when we look at the table, a sub 1 is equal to 4. Then what number did we add to arrive the value of 7? That is 3, which is our common difference. Then for the third term, the a sub 3, we have a sub 2 plus d. Now let's break a sub 2. And what is a sub 2 again? That is a sub 1 plus d. Then we just need to add another d. So in short, a sub 3 is equal to a sub 1 plus 2d. And goes with the rest of the term. When we move to the next term, the variable d also increases. So the fourth term will be a sub 1 plus 3d. So to identify the general rule of the nth term, it will be a sub 1 plus n minus 1 times d. And the rule applied to this activity is a sub n is equal to 4 plus n minus 1 times 3. Then, we distribute 3 to n minus 1. So it becomes 3n minus 3. Combine 4 and negative 3, you get positive 1. Therefore, the rule will be 3n plus 1. This is what you are going to use to find the missing term of the sequence. So the general term a sub n of an arithmetic sequence can be written in terms of the first term, the a sub 1, and the common difference, which is the d. Thus, the general term of an arithmetic sequence is a sub n is equal to a sub 1 plus n minus 1 times d, where a sub n is the nth term and a sub 1 is the first term, n is the number of term. So whatever is your nth term, the same number is represented in your n. Then d is the common difference. Let us apply what we have learned in this lesson. Let's take this example. What is the 10th term of the arithmetic sequence 5, 12, 19, 26, and so on? To find the 10th term of the sequence, let us start by identifying the given in the problem. 5 here is our first term, 12 is our second term, 19 is our third term, and 26 is our fourth term. In our general rule, which is a sub n is equal to a sub 1 plus n minus 1 times d, a sub n is a sub 10, since we are looking for the 10th term. A sub 1 is, which refers to the first term, and that is 5. N is 10. That refers to the position of the value we are looking for. And D is 7. We get 7 by subtracting 12 with 9. Now let's substitute with the formula. So it will be a sub 10 is equal to 5 plus 10 minus 1 times 7. Then let's subtract 10 with 1. We get 9. Then we multiply 9 with 7. We get 63. Then add 63 with 5. So our value for the 10th term of the sequence 5, 12, 19, and 26 is equal to 68. What will be the pattern you will use to solve any term of this sequence? It will be a sub n is equal to 5 plus n minus 1 times 7, or a sub n is equal to 7n minus 2. So if you will use this pattern in solving the 10th term, you will still arrive with the same answer, which is 68. Let us take another example. Let us find the missing value of this sequence. Let us first find the unknown terms. Since 5 is the first term, 16 is the second term, 27 is the third term, the next two blanks will be the fourth and the fifth term, 60 is the sixth term, and the last blank is the seventh term. So our unknown terms are the fourth term, fifth term, and the seventh term. Let us identify the values of our first term and the common difference. So our first term is 5. And to find the common difference, we need to subtract 16 with 5, and that is 11. So our D is 11. Then let's substitute those values in the formula. A sub n is equals to A sub 1 plus n minus 1 times D. So A sub n will be A5 plus n minus 1 times 11. Then distribute 11 with n minus 1. It will be 11n minus 11. Then combine 5 and negative 11. So our pattern to identify those missing terms will be A sub n is equal to 11n minus 6. Now let's solve those unknown values. Let's start with the fourth term. Using the pattern, A sub n is equal to 11n minus 6. A sub n will be your fourth term. A sub 4. N is 4. So it is 11 times 4 minus 6. Then multiply 11 with 4, we get 44. Minus 6, which is equal to 38. Therefore, our fourth term is 38. Let's now solve the fifth term. Again, using the pattern, A sub n is equal to 11n minus 6. An now is A sub 5. N will be 5, so it will be 11 times 5 minus 6. Multiply 11 and 5, that is 55. Then subtract it to 6, so our fifth term is 49. Next is to find the seventh term. Again, let's follow the pattern. A sub n is equal to 11n minus 6, where A sub n is A sub 7. And n is 7, so it will be 11 times 7 minus 6. Multiply 11 with 7 equals to 77. Minus 6 is 71. So our seventh term is 71. Therefore, our missing terms are 38, 49, and 71. Hope you followed the steps and can find the missing term on your own. Let's have another example. Find the general term for the sequence 9, 12, 15, and 18. Since we are looking for the general term of this sequence, let us first identify the first term and the common difference. The first term is 9 and the common difference is 3. We get 3 by solving 12 minus 9 from the sequence. Then substitute these numbers in the formula. A sub n is equal to A sub 1 plus n minus 1 times D. So we have A sub n is equal to 9 plus n minus 1 times D. Then distribute 3 to n minus 1. We get 3n minus 3. Then combine 9 and negative 3, so our general rule or pattern for this sequence is 6 plus 3n or 3n plus 6. For our last example, we are going to find the general term of the arithmetic sequence whose third term is negative 13 and the seventh term is negative 37. Is there a way for us to find the general term of this sequence, even if we only have the value of the third and the seventh term? Yes, we can. Remember, in finding the general rule of the arithmetic sequence, we only need to identify two given values, the first term and the common difference. And we can find the values of the first term and the common difference using what is given in the problem. Before we solve the common difference, let us solve first the formula for the third term and the seventh term. The value of the third term, which is equal to negative 13, And remember that the formula of getting the value of the third term is a sub 3 equals to a sub 1 plus n minus 1 times d. Then n minus 1 will be 3 minus 1. So substitute a sub 3 with its value, that is negative 13. Then 3 minus 1 is 2. So our formula to use is negative 13 is equal to a sub 1 plus 2d. For the seventh term, the value is negative 37. The formula to solve the seventh term is a sub 1 plus 7 minus 1 times d. Substitute again a sub n to negative 37 and subtract 7 minus 1, which is positive 6. So we get this formula. Now let us solve for d by subtracting both formula. Negative 13 is equal to a sub 1 plus 2d minus negative 37 is equal to a sub 1 plus 6d. Remember again the rule in subtraction. We need to change the sign of the number to its opposite sign. So negative 37 will become positive 37. Positive a sub 1 will be negative a sub 1. And positive 6d will be negative 6d. The answer for negative 13 and positive 37 is 24. We cancel a sub 1 and negative a sub 1. And positive 2d and negative 6d is negative 4d. Then let's transpose negative 4 in negative 4d by dividing it by its own, negative 4. And divide also negative 4 on the other side. So 24 divided by negative 4 is negative 6. And negative 4d divided by negative 4 is d. Therefore, our common difference is negative 6. To find the first term, which is the a sub 1, you can either use the formula of negative 13 or negative 37. Let's just use negative 13, a sub 1 plus 2d. Now since we just only solved the common difference, which is the d, we can substitute it in the formula. Negative 13 is equal to a sub 1 plus 2 times negative 6. 2 times negative 6 is negative 12. Transpose the negative 12 to the other side of the equation. We need to remove negative 12 by pairing it with its opposite value, and that is positive 12. And since we add positive 12, we also need to add positive 12 to the other side of the equation so that the equation will be a sub 1 is equal to negative 13 plus 12. And what is left is negative 1. And there you go. We have our first term. Hence, our general term is a sub n is equal to a sub 1 plus n minus 1 times d, wherein a sub n is equal to negative 1 plus n minus 1 times negative 6. Then distribute negative 6 to n minus 1. We have a sub n is equal to negative 1 minus 6n plus 6. Therefore, our general term is a sub n is equal to negative 6n plus 5. There it is. If you still have confusions with what we just did in the lesson, you can go back and review the steps until you attain mastery. If you are ready, you can answer the next activity given in your module. Now pause this video again, and I want you to answer the activity found in your module. Just play this again when done, or you can play back the video if you encounter some problem. Remember, to get the next term of an arithmetic sequence, you just need to determine the common difference and add it to the number before it. And to determine the nth term of an arithmetic sequence, you just need to use the formula a sub n is equal to
a sub 1 plus n minus 1 times d, where a sub n is the nth term, a sub 1 is the first term, n is the number of terms, and d is the common difference.
That's it. Congratulations. You are now done with this lesson. See you again for our next topic. Bye! Don't forget to like this video and subscribe to my channel for more video lessons in mathematics.